umbra and penumbra. Which one is the darkest region? Umbra. What on, sir? We have umbra, we have penumbra. Opano has taught you perfectly well the pinhole camera. For pinhole camera, if you are going to get a very sharp image, the hole should be small or large. Small, MV over U. Also have HI over H naught. If you want to get a brighter image, brighter image, the hole should be small or wide. Small or wide. There's a difference between sharp image and brighter image. For sharp image, the hole should be very small. But for brighter image, the hole should be very wide. Note it all. For sharp, very sharp. What is the opposite of sharp? Blurred. B-L-U-R-R-E-D. So it can be sharp and not bright. And it can be bright and not very sharp. Oh yeah, question 1. We are through with the topic. Very short. Let's go. Question 1. Are you true? Which of the following phenomena is not a direct consequence? Which of the following phenomena is not a direct consequence? Is not a direct consequence. So the following phenomena is not a direct consequence of rectilinear propagation of light. Is not a direct consequence of rectilinear propagation of light. Rectilinear propagation of light. Rectilinear propagation of light. Rectilinear propagation of light. Option A, lunar and solar eclipses. Lunar and solar eclipses. Lunar and solar eclipses. Lunar and solar eclipses. Then option B, images of objects in a pinhole camera. Images of objects in a pinhole camera. Images of objects in a pinhole camera. Option C, diffraction of light. Diffraction of light. Diffraction of light. Diffraction of light. Option D, shadow of opaque objects. If you can't spell opaque, right? Opakwe. Shadow of opaque objects. Shadow of opaque objects. No sleeping, baby girl. Class, what's the answer? Diffraction. See, once you are rectilinear propagation, two things are expected from you. What are they? Eclipse and anything different from that is not part of the consequence of rectilinear propagation of light. Let's go. Number 2. This one should take us like 30 minutes. We are through with the topic. Which of the following is not a luminous object? Which of the following is not a luminous object? Which of the following is not a luminous object? Which of the following is not a luminous object? Option A, the sun. The sun. Option B, the moon. The moon. Option C, light candle. Light candle. Option D, star. In this your exam, you become a star. Yeah, the pressman will be looking for you to interview you. Star, star, star. Class, what's the answer? Moon. Let's go. Number what now? Light traveling through a small pinhole. Light traveling. Light traveling through a small pinhole. Through a small pinhole. Usually does not make a shadow. Usually does not make a shadow. Usually does not make a shadow with a distinct sharp edge. Does not make a shadow with a distinct sharp edge. Because of, does not make a shadow with a distinct sharp edge because of, option A, diffraction. Option A, diffraction. Option B, interference. Option B, interference. 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 Option C, reflection. 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 Option D, refraction. Refraction. Oh yeah, pick one answer. Don't bail, don't bail. Make sure you get it. Think. 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 When I should have finished thinking. Yeah. Okay. What's option A? Option B? Option C? Option D? Pick one, oh, pick one. Pick one. I'm going to ask you to raise your hand. And you must raise it. By all means. You think the answer is, what's option A, Seth? You think the answer is A, raise your hand. Put down your hand. You think the answer is B, raise your hand. What's B? Don't forget, you have to raise your hand for one. No? If you want admission, raise your hand. Good. What's option C? You think the answer is C, raise your hand. Raise it very well. Don't do like this. Raise it. What's option D? If answer is refraction, raise your hand. Raise it. Now come me simple question, all of you. I love that. And that's to let you know that you don't have to cram something. You have to know things. Oh, yeah, read the question again, everybody. Light traveling through a small pinhole. Let's say this is a pinhole. Small pinhole. Oh, yeah, go on. Light traveling through a small pinhole. Yes, go on. Does not make a shadow, yes? With a distinct sharp edge. Because of class, we have just been taught waves. When waves get to a narrow something, what happened to the light? Diffraction, that's the answer. Instead of it to be very concentrated on that point, they will not spread. They spread. Because it's narrow. So instead of to have a very sharp image, you won't get sharp image again. It's narrow, this is narrow. So by the time the light ray get here, instead of to go straight like that, it now begin to spread. So for you to get a distinct sharp image, you don't get it. What a question. I've not seen it also before. First time I'm saying that. So it will, instead of to go straight like that, it starts spreading at that junction, at that corner. Instead of to get a distinct image, it spread. What a question. So that thing, something will have given you an idea, because it's a small aperture. When waves get to a narrow aperture, what will happen to them? They undergo diffraction, spreading out. Oh yeah, number what are we? Number 4. The direction of the path taken by light. The direction of the path, PATH. Direction of the path taken by light. Direction of the path taken by light is called. Direction of the path taken by light is called. Option A, locus. Locus. Option B, line. Line. Option C, ray. Ray. Option D, beam. 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 Pick one. If you miss that one, Egba, you deserve Egba. Beam. Beam. Class, what's the answer? Ray. Next question. Number what now? Non-luminous objects. Non-luminous objects can be seen because they non-luminous object can be seen because they, option A, emit light. Emit light. Option B, are polished. They are polished. Are polished. Option C, are near. They are near us. If they are far, we can't see them. They are near. Near. Option D, reflect light. Reflect light. Class 1, pick one. Pick one. There's some going like this, you don't have to miss. You should get all of them. Are you true? Very good. What's the answer? They reflect light. Listen, you are seeing by the light you reflect to my eye, a green leaf appear green. Why? It absorbs other color and reflect green light to my eye. A paper appear blue. Why? Because it reflects blue light to my eye and absorb the remaining color. So they reflect the light. They don't emit light on their own, but they can reflect. Let's go. The next question. Number what are we now? Number 6. Well, just to fill in the gap because we know the answer, but let's write it for revision. The eclipse of the sun occurs when 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 the I think we can just put the answer. Answer. Moon, Abby. Is between the sun and the earth so that we don't waste time. Moon is between the sun and the earth. Sun's me. Moon is between the sun and the earth. Moon is between the sun and the earth. Between the sun and the earth. Next question. Number what? Number 7. An object of height 20 centimeter. An object of height 20 centimeter is 1 meter away. Is 1 meter away from the pinhole. Is 1 meter away from the pinhole. Is 1 meter away from the pinhole. Full stop. If the camera is 40 cm long, if the camera is 40 cm long, 40 cm long, comma, how high is the image? How high is the image? How high is the image? Classwork, try it. How high is the image? How high is the image? Don't forget, M is what? V over U. Image height over what? Object height. Are we true? The camera lens represents the what? Image distance. Oh, so we don't know. Our M is V over U. Image distance over object distance. Image height over what? Object height. The length of the camera is the image distance. How much is the length of the camera? 40 centimeter. How far is the object to the camera? 1 meter. That's 100 centimeter. Make everything centimeter. Want to find image height? What's the object height? I can't hear you. 20 cm. Shh. So we're gonna have the answer is in centimeter. I know what I'm trying to do. 100 hi equals 800. Is answer 8? That's the answer. 8 centimeter. 8 centimeter. So the camera length is your image distance. Camera length is your image distance. Question number 8. Very good. It's a simple topic. And then we'll now go to play mirror. An image formed on a screen. An image formed on a screen. An image formed on a screen. An image formed on a screen is always option A, inverted. Option A, inverted. Option B, magnified. Magnified. Option C, upright. Upright. Option D, visual. Visual. Pick one answer. You have 10 seconds. Pick one answer. What's option A? Option B? Option C? Option D? What's the answer? Hey! What's the answer? Shy. Visual. Inverted. Visual image cannot be formed on the screen. Cannot be formed on a screen. So if you are visual, it can't be formed on the screen. Real image. Real image can be what? Can be formed on a screen. So when you say something is real, you can form it on a screen. And this is when all the problem of I'm confused will end, because some of you are confused on light. I've told you before, but you have forgotten. Once you are real, you are inverted. Real and inverted, they go together. You can't be visual and inverted. There's only like that. So I'm going to give you the formula now. Real and inverted go together. Visual and what? Upright. You can call it erect or upright. Which one do you want? Do you want erect or upright? Erect, okay. So that would be rive. So once you are real, you are what class? Inverted. Once you are visual, you are what? Whether you are a lens, you are a mirror, you are a PO camera, that's it. Rive. Or very, or rival. Upright for you. So that is the rive. Another word for erect is what class? Upright. Oh yeah, look at the option now. There are two things that are the same thing. Check. What and what? Upright and visual. So that means the two of them are wrong. Magnify can be anyone. Can be real and be magnified. Can be visual and magnified. So when you are real, you are what class? Inverted. When you are visual, you are what? You are erect. So the answer is what? Inverted. Because it is real. Number what now? Number 9. If you miss this one, just come for Cain. The image in a pinhole camera is always the image in a pinhole camera is always the image in a pinhole camera is always option A, diminished. Option B, enlarged. Option C, upright. Option D, inverted. Pick one answer. Inverted. Anyone true? Some of you have not seen people on the camera before. Some years ago in Adams College, during jam class, they always tell students to do it as practical. Everybody will bring their pinhole camera to the class. Class, what's the answer? Inverted. Why is it inverted? Because it is real. Number 10. I want to give one that is difficult. Last one. They are repeating the same question for that one. Okay, let's just take it like that. I was trying to avoid repetition, but I have no choice. But I'm repeating the same question for that topic. Ten. All the one I'm seeing are simple. I want tough question for you. The one you can easily miss. Okay, we'll manage it. The size of the hole of a pinhole camera. The size of the hole of a pinhole camera. The size of the hole of a pinhole camera is increased. Full stop. The resultant image becomes, the resultant image formed becomes, the resultant image formed becomes option A, sharper. Sharper. Option B, reduce in size. Reduce in size. Option C, enlarged. Enlarged. Option D, blurred. B-L-U-R-R-E-D. Blurred. B-L-U-R-R-E-D. Option A, sharper. B, reduced in size. C, enlarged. D, blurred. What's the answer, Claude? Blurred. So we have finished 10 questions. That's topic 23. I mean, we have already solved 230 questions. We'll go to topic 24. Yeah, medical, I give you some general, don't count those ones. Okay, reflection of light at plane and curved surfaces. Reflection of lights. Yeah, I'm happy your chair has really done so much justice to all this. At plane, so it's easier. And curved surfaces. Topic 24. For plane mirror, image 1, visual. 2, erect. 3, same size as objects. No story, is revision. Number 4, magnitude is 1. That's the M is 1. Number 4, laterally inverted. Laterally inverted. What does that mean? Your left becomes the right. Abby? Abby? Laterally inverted is different from inverted though. Laterally inverted means when you stand before mirror, your left hand becomes the right. If you are raising your left hand like this, in the mirror, your right hand is the one being raised. That's what they call lateral inversion. So you can use this one to form vessel. Visual, erect, same of objects, and laterally inverted. So that's that. And then number of images formed, 360 over theta minus 1. We all know that. Then law of reflection. Angle of incidence equals what, class? Angle of refraction called reflection. So our I equals R, Rabina. So all these are what you've been taught, so no big deal with all this one. I equals R. Rotated mirror. When a mirror is rotated, what happens to the reflected ray? Rotated by 2 theta. If a mirror is rotated by theta degree, comma, reflected ray is rotated by 2 theta. Then angle between the incident and reflected will now be 2I plus 2 theta. We'll see examples, so I don't want us to write story. Because it's revision, you have the note already, just capsular form. Use of mirror. Use of plane mirror. Number 1, periscope. You know periscope? For observing what is going on in the neighborhood without being seen. Yeah. Some of you that are used to take your bath outside, all those boys and girls, people can be observing you without being seen. You use periscope. Am I with me? Number 2, kaleidoscope. Kaleidoscope. So periscope is a device. You can use periscope to watch football without going to the stadium. Or your own periscope must be very long. You have kaleidoscope as well, periscope. We have sextants for measuring what? Angle of elevation of the sun. These ones, anyway, I'll give you examples and what we need to know about them as we solve questions. These are the three uses. Then curved mirror. Curved mirror, we all know what happened. 1 over U plus what? 1 over V is what? 1 over F. I know that U is what? F into 1 plus 1 over M. And then we have V is what? F into what? 1 plus M. And your F equals what? R over 2. For convex mirror, Mr. Convex Mirror will give you convert. Do you remember convert? Once your name is convex, this is your spelling. This is how we spell convex mirror in Adams College. That means if you are a convex mirror, your image must be what? Virtual. That's it. Erect and diminished. Very important. Once you are a convex mirror, your image is always virtual, erect and diminished. No cramming. Then for a concave mirror, we have about 5 stages. Do you remember the 5 stages? Before the curvature, between curvature and focal length, this is your F, this is your C, like that. This is our focal length, this is our curvature center. This is real inverted and same side. This one is where real inverted and magnify, rim. This one is what? Read. RID, real inverted and diminished. This one is fem. Is there any song like fem? This is fem. Virtual erect and what? Magnify. This one is what? Infinity and parallel beam. Pi. So there are 5 stages for concave mirror. For convex mirror, only one thing happens in convex mirror. The image is what? Virtual, erect, and what? Diminished. For concave mirror, beyond C, image is real, inverted, and diminished. At C, real, inverted, and same size. Between C and F, we call real, inverted, magnified. At display, parallel beam is formed, and image is at where? Infinity. Here, virtual, erect, and what? Mr. Concave Mirror can only give you erect image only when the object is between what? Focus and the pole. Focus and the pole. Mr. Concave Mirror can only give you a virtual image when object is between focus and the pole. Focus and the pole. Otherwise, that's what you have. So that's the topic 24. Through examples, we add more light. Let's keep all this on note, especially the revision one. That's the thing we should spend more time with now. Don't go and be reading things that will be confusing you. Exam has come. Mr. Adams, my problem is all this sign, negative, positive, something. If that's your problem is solved. Because that's not a problem. Let me give you. Once you hear convex mirror or diverging mirror, once you are convex mirror or diverging mirror, every time your F must be negative. Your M must be negative. your V must be negative. That's all. So anywhere they appear, once you have a convex mirror of focal length 10, just go write minus 10. A diverging mirror of focal length 15, just write minus 15. That's that. Then concave mirror, concave to converging mirror, concave to converging mirror. Our F is positive, but our M can be anything, depending on the nature of the image. Class, if you are real, what happens to your V? Your V is positive, and your M is positive. And then when you are what now? When you are virtual, your V is negative. So just take some few examples. Question 1, let's go. An object is placed on the principal axis. An object is placed on the principal axis. An object is placed on the principal axis and at the center of curvature of a concave mirror. An object is placed at the principal axis and at the center of curvature of a concave mirror. And at the center of curvature of a concave mirror, comma, the image of the object formed by the mirror is the image of the object formed by the mirror is the image of the object formed by the mirror is option A, real and magnified. Write the option. The image of the object formed by the mirror is option A, real and magnified. Option B, real and inverted. Real and inverted. Option C, erect and magnified. Erect and magnified. Option D, erect and visual. Erect and visual. Oh yeah, pick one answer. You have picked your answer, raise your hand. Mogbe, what am I? I've given the answer on the board now. See the board. That means what is on the board, you don't understand the meaning of what I've written. Class, read the question. Let me hear. On the principal axis, yes. And at the center of curvature, see it here at this place. At this place. The image is what and what class? Real, inverted, and that's it now. Which option has real and inverted? Eh? That's the answer. So why are you not raising your hand? That's it. So that's it. So this is what people don't understand every time in jump. Mr. Dan, can you draw a diagram? Why not? I don't want to start wasting time drawing, but I can draw for you. Like the pim. This is your F. Pim, 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 pim. This is your C. This is the object. The rule says when you first want to draw image rays, the first ray must be parallel, like this, parallel. And a ray parallel must go through F. Yeah, go through F. That's it. Go through F. Yes, sir. Then the second ray will pass through what it is closer to, towards the mirror. I am here. I can't pass through C again. So I have to pass through F. And the rule says, once you pass through F, you must be parallel. So see the image here. That's it. So the image is real. So why is it real? Because it's inverted. Once you are inverted, you are real. The image is inverted, it is real, and the same size as the object. In fact, it's also at the center of curvature. That's all. That's the meaning of real, inverted, same size as objects. 1 down, 9 more. Number 2, no time. Oh. So please use those tables. Use that one. Go and store it. Read, raise, rem, pi, and vem. Like that. Question 2, we are going. The image of an object pin. The image of an optical 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 pin placed at the principal focus. Placed at the principal focus. Placed at the principal focus of a concave mirror. Placed at the principal focus of a concave mirror will be formed. Placed at the principal focus of a concave mirror will be formed. Will be formed. Option A, between the principal focus and the pole. 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 Option B, at the center of curvature. 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 Option C, between its principal focus and the center of curvature. Between the principal focus and the center of curvature. Between the principal focus and the center of curvature. Between the principal focus and the center of curvature. Option D, at infinity. At infinity. At infinity. Yeah, pick one answer. Have you got one answer? Others were waiting for you. Class, what's the answer? At infinity, pi. At that F, that P means parallel beam is formed, and I means the image is at where? Infinity. Number 3. If an object is placed, if an object is placed between two parallel plane mirrors, if an object is placed between two parallel plane mirror, with their reflecting surfaces, facing each other, comma, how many images of the objects will be formed? How many images of the object will be formed? Classwork, try it. Are you true? We have written the number of images formed. Oh yeah. Number of images formed is 360 by what? Minus 1. When you are parallel, that means theta is 0. That's the meaning. When you are parallel, it means theta is 0. And in mass, 360 by 0 is undefined. That's infinity. That's the answer. Infinity. So when they are parallel, you are going to have infinite number of images. So for parallel mirrors, we should expect infinite number of images formed. Next question, number what? A ray from a fixed object. Is incident on a plane mirror. At an angle of 20 degree. Full stop. If the mirror is rotated through 30 degree. If the mirror is rotated through 30 degree. Comma. By how many degrees will the reflected ray rotate? If the mirror is rotated through 30 degree, comma, by how many degree will the reflected ray rotate? By how many degree will the reflected ray rotate? Classwork. I wrote it for you today. Oh. Don't be looking around. Oh. When you rotate a mirror by theta degree, reflected ray will be rotated by how much? That's the answer. Oh, 2 theta. 2 theta. 2 times how much now? So what's the answer? That's all. Low button. 2 theta. Next question. Number what? An object is placed 10 cm. An object is placed 10 cm in front of a plane mirror. An object is placed 10 cm in front of a plane mirror. In front of a plane mirror. Full stop. If it is moved 8 centimeters further away, if it is moved 8 centimeters further away, Sarah, let me call Sarah that is going down. Ugoji. Yeah, come. 8 centimeters further away from the mirror. Come on. Determine the distance of the final image. Determine the distance of the final image from the objects. Distance of the final image from the objects. Class 4, let's try it. Anyone true? Cheta, what did you get? I was looking for you. What did you get again? You ran away. What did you get? Read the question, let me hear. I can't hear you. The object is here, 10 cm. Oh yeah, go on. What was moved? Object is moved what? They move it here. The object is now here. So this is 8 centimeters. What they say we should now find? So why did you not get 18? 18. If you move the object like this, 8, the image also will be moving away. So the image will be here, 18. So this is 18. Mr. Adams, how do you get 18? From here to the object now 18. And one of the rules says the object distance equals what? For a plane mirror. So if from here to here is 18, where the image will be, will also be 18. So we're now looking for the distance from where? Distance of what? From the object. This is the object now. The answer is 36. The object is now here now, 18. Am I communicating at all? If you move it to by 8 centimeters, I mean from here to here will be 18. And then from here to here will also be 18. Image distance and object distance for a plane mirror are the same. So we want to find from here to this place. So answer is 18 plus 18. So answer is 36, not 18, no. 36 centimeters. Object distance is equal to image distance. I explain again. From here to here is 10. They now move the object 8 centimeters further away. Further away means further away. That means it's no longer closer to the mirror. Further away. 8. So from here to here now is 18. This is the object distance. And image distance also will be 18. Then 18 plus 18 will now be 36. Next question. Number what? Number 6. Number 6. When an object is placed at the center of curvature, when an object is placed at the center of curvature, when an object is placed at the center of curvature of a concave mirror, when an object is placed at the center of curvature of a concave mirror, center of curvature of a concave mirror, comma, its image is formed at option A, the focus. Image is formed at option A, the focus. Option B, infinity. 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 Option C, the center of curvature. The center of curvature. Option D, a distance twice the radius of curvature. A distance twice the radius of curvature. Oh yeah, classwork. You have gotten your answer, raise your hand. Raise it very well so that you can start building confidence. Where did they place the object? At where? And then we wrote real sabi, real inverted and what? Same size. I mean the answer will be at the center of. Very good. Next question. Number what? 7. The distance between a concave mirror. The distance between a concave mirror and an object placed in front of it is 1 meter. The distance between a concave mirror and an object placed in front of it is 1 meter. And an object placed in front of it is 1 meter. 1 meter. Full stop. If the radius of curvature of the mirror is 4 meters, if the radius of curvature of the mirror is 4 meters, is 4 meters, comma, describe the nature of the image. Describe the nature of the image. Oh yeah, classwork. Describe the nature of the image. One is tired. Yeah, well, you're not the only one, no. Akpo. And chemistry is loading. Oh, it's true. See, a coin like this don't have to solve it. They have to describe nature. Look at this. This is your mirror. Are we given the radius of curvature? How much? 4 meters. So I will see this. I mean, this is 2 meters. This is 2 meters. It's another 2 meters, making 4. You don't need to even draw. Then what's the object? Object is what? 1 meter. That means the object is somewhere here. And when you are from here to here, your image is what? Virtual. What again? Erect. What again? That's what they're asking to do. I'm not asking to do all the calculation you are doing. They said the nature of the image. virtual. Mr. Dan, can we prove all those things from that calculation? The babe at the door there is already sleeping. Your eyes are closing. Yes, it's closing. Fresh air, Virtual, erect, magnified. That's what it has to do. So you don't need to go and start solving. From here to here now 4. Half of it is 2. Object is now 1 meter away. And once you are here and here, I give you vem, virtual. And that's what it has to describe. So can we find it? Can we work it? Why not? F is R over 2. R over 2, what would that be? 4 over 2. That's 2 meter, Abi. And then you are given U. What's your U? 1 meter. So that's 1 over U plus 1 over V is 1 over F. 1 over 1 plus 1 over unknown is 1 over 2. 1 over V will now be 1 over 2 minus 1 over 1. 1 over V, SN will now be 2. 1 minus 2. 1 over V will now be minus 1 over 2. Our V will now be minus 2. That minus 2 means you are virtual. And once you are virtual, you are also erect. Virtual go with erect, I've told you. Can I find M? M now waiting. V over U. What's your V? 2. Forget about the minus. What's your U? 1. M now 2. Because you are more than 1, that means you are also magnified. But a smart student will not even work all these things. We'll just use them. So the answer is virtual, erect, and magnified. That's the nature of the image. Virtual, erect, and also magnified. Are you learning something? Virtual, erect, magnified. Question 8. Question 8. The angle of incidence of a ray of light. The angle of incidence. The angle of incidence on a ray of light on a plane mirror. The angle of incidence on a ray of light on a plane mirror is 55 degrees. Is 55 degrees. Full stop. Determine the angle of deviation of the ray. Determine the angle of deviation of the ray. Angle of incidence is 55 degrees. Determine the angle of deviation of the ray. Class work. Angle of deviation of the ray. Angle of deviation of the ray. When a ray hits a plane mirror, the ray will undergo deviation. So what does that mean? I was coming like this. This plane mirror. Coming like this. Pam. This is my normal. So I'm going to keep on going like this. Turn, 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 turn. And I underwent this deviation. I should have gone this way. This way. I can't reflect. And the angle of incidence equals what? Somebody. That means this is also I. This angle here is called angle of deviation. It's called what? Class, this is a straight line. What's one of angle on a straight line? That means I plus D equals 180. So your D will now be 180 minus I. So the formula for angle of deviation, 180 minus 2I. That's the answer. 180 minus 2I. That's angle of deviation. 180 minus 2I. So angle of deviation will now be 180 minus 2 into, what's your I? 55. So now 180 minus 110. So what's the answer? 70 degrees. Mr. Adams, can I find what they call glancing angle? Yes, this is G. Glancing angle. You know, so the two of them must give us 90. So G plus I, this is another method. G plus I is 90. G is called glancing angle. So that G now will be 90 minus I. That will be 90 minus how much? 55. That's 35. An angle of deviation is twice the glancing angle. So that's 2 times 35. So any method you use, 70. Michael, my question, chemistry, bring them here. Number what are we? Number 9. Number 9. The following devices use plane mirrors in their operations except the following devices use plane mirrors in their operation except, I'm giving the answer today. Option A, periscope. Option A, periscope. Option B, sextant. The following devices use plane mirror in their operation except A, periscope. Option B, sextant. Option C, kaleidoscope. Kaleidoscope. Option D, binocular. Binocular. Class, what's the answer? Binocular. Question 10, last question. The image formed by a convex mirror is always I'm going to give you the 4 options. If you miss it, just carry your book and go home. Go and sleep. The image formed by a convex mirror is always option A, real, erect, and diminished. Option A, real, erect, and diminished. Real, erect, and diminished. Option B, real, inverted, and diminished. Real, inverted, and diminished. Option C, visual, inverted, and diminished. Visual, inverted, and diminished. Option D, visual, erect, and diminished. Class, what's the answer? Visual, erect, and done and dusted. So by God's grace, we have done how many topics now? 20, 24. Remain 15 to make 39. The last ones are easier, but we'll still do them. By God's grace, we'll finish them. Amen. So no class tomorrow till Thursday. So Thursday, we should be able to do 4 more. Friday, like 2, 3. Like that. Saturday, 2, 3. So we just go to lenses. The next class, by God's grace. Lenses and which one? Refraction and lenses. And then optical instruments. 2 more on lights. Governors, you on ground floor, Petit, Victoria, IBK, come and take question. VIP representative, Elijah and Co, come and take question. Yeah, Elijah. Glory, take it to the back. Start from the last row. Indomie representative, come and collect too. Elijah, give them. Pass it. That corner where you have the restroom, from where Glory is standing. You don't have question, raise your hand. Okay, see those hands there. Glory, come and take more. Please don't take don't take two. Pass one to the other person. Move towards the middle now. Governor. You don't have question, raise your hand. I see those hands. See those one at the middle. Pass it, pass it. Take one and pass. At the back there, move to the remaining one to the front, to the middle. Don't take two, please. Just the rough estimates. You don't have question, raise your hand. At the middle here, Michael, we need about, this is almost 50. Oh. Ground floor, you don't have question, raise your hand. Shemilori and Elijah, you should have more than enough. So, remember extra, give them at the middle. Michael, we need like 100 more questions. Pass this one to the middle for two people. Pass it. Okay, while we wait for question, let me give you some organic compound to name while we wait for the remaining question. So suspend the reading. Don't read yet. Keep the question somewhere. You see the one, let me see your hands again so I can estimate the copy. Okay. So Michael, let's have like 100 copies more. Thank you. Let me give you some questions to name. 10 questions, name them. Let me see how many you can get. Oh yeah, name the organic compounds below. 1. That's my 1. Number 2. That's number 2. No talking. Number 3. That's 3. Number 4. Number 5. Please, the governor of Victoria, please monitor how many hands we need left in the ground floor after the remaining questions from other section. So ground floor, please, can you just raise your hand? You don't have question. So Victoria, just use your eyes, estimate the few number of people. Let me have just a rough estimate. You don't have question. Indomie stand, the VIP section, and of course the main auditorium. $25, thank you. So 100 should be okay. That's a good estimate. We're just giving this one so that we can save some time, do something. Name the compound. Oh yeah, quickly. 7 compound. Oh yeah, you don't have copy. Raise your hand. Make the floor. Yeah. Oh yeah. Michael, thank you. Are you doing more? Okay, thank you, sir. So will that be jam lectures when jam starts? Yes, so jam class is not ending Adams until the last day of jam. That means if your own exam is 29, you'll be coming to class at 28. We're not saying yes, lecture ends on Thursday next week. Never. If your own exam is 27, you'll be coming. Except if you don't want to come. Or we have classes. Someone is asking, when is the jam class starting? May. I think May 6th or so, the first Monday there. There is optional now. We're not asking you to come by all means. It's meant for those that will score above 300. And so if you are complaining, what's my business with that? It's May, June, July, August. So you can decide not to come. You don't have question, raise your hand. Middle floor, yeah? Okay. We are aware that some of you are writing May, June. So when you finish your May, June exam, you join us. We're not waiting. But to prepare you for university exams, part 1 exam, entrepreneurship training, coding classes, Chinese class, and all that. It's a bumper package. The middle floor here, you don't have question, raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, about 18. That's good. Number has reduced. By now, you should have been through with the naming. You don't have question, raise your hand. Middle floor here. Okay, they are bringing. If you get 7.7, that means you are a top-notch student. Divine, where is your glasses? Eh? Broken. Who broke it? So how do you want to see now? Ah. The fellow that broke it, you bring the fellow to my office after class. It's straining your eyes, oh. Where are the names? You are true, raise your hand. To money me into your long. Sonny, are you true? Okay, by now it should be true. You know what you are doing. See, don't go and write tetramethylmethane. Because some of your thinking is strange. You have to draw it out. See H3. There are 4 of them, so you draw it out like this. Don't come and be naming rubbish. Oh. That's it. That's temptation. You draw it out. The 4 of them, you draw them out. So now number 1, 2, 3. This methyl on carbon 2. So that'll be 2 dimethyl propane. That's the name. Oh. Who got his? Raise your hand. Very good. Not tetramethylmethane. What is that? Number 2. This is, you must count this carbon. No? 1, 2, 3, 4. That chlorine was not part of them. That will be on carbon 2. So say 2-chloro. Because you have 4. Butanoic acid. That's the name. 2-chloro-butanoic acid. Chlorine on carbon 2. Your numbering must start from the functional group, COH. You don't have question now, raise your hand again for the last time. Michael, please. Thank you. That's it. 2-chlorobutanoic acid. Who got that one? Anybody? Very good. Then the next one. Your numbering can go anyhow. Like I can go like this. Let's go like this first. 1, 2, 3, 4, 5. 5. You don't have raise your hand in this floor. They don't take 2. Pass the remaining one now. See their hand. You are still raising hand. Just take one and pass to the other people. Okay, please monitor so that they will not waste it. Oh. So this is chloro. That's C for chloro. This is methyl, M for methyl. So when you are naming, you name them alphabetically. You don't have question. Raise your hand again for the last time here. 1, 2, 3, 4, 5, 6, 7, 8. So this is chlorine on carbon 2. So that's why it's 2 chloro, 3 methyl. That's the name. Pent 5. 2 in. So we have gotten 0/3. Oh. Go to LAMLAD, you see many questions there. Go to past question, jam series, you see many naming there. Name them. This one. Now, because this guy is symmetrically related, what you have on the left and what you have on the right, they are the same. CH3, CH3, Cl, Cl. And because they are alternated, this is called trans isomer. It's called what, somebody? So you are going to have trans before I name it. This 1, 2, 3, 4. So why trans? Because they are alternated. Trans 2, 3, dichlorobutuene. That's the name. That's the name. You don't have a copy of chemistry in this floor. Raise your hand. Where were you when they were giving copy now? Okay, you and Glory don't have. Downstairs, raise your hand. You don't have copy so that Michael can give you. So that's the answer for that one. Trans 2, 3 dichlorobutuene. Number 5. Let me number like this. 1, 2, 3, 4, 5. So what would the name be? 3, 4 dichloropents 3 in 1 I. That's it too. Okay, we need 2 copies here for Gloria and one girl here. That's it. Again, sir. 1, 2, 3. This one has double functional group. So we have 1, 2, 3, 4, 5. Chlorine on carbon 3. Chlorine on carbon 4. 3, 4 dichloropent 3. Got this. 3 in 1 triple bond iron. Number 5. Okay, we need 2 copies here. Ground floor is what I'm waiting for. Once you are through, let me know, please. So yeah, can number like this. 1. Some of you missed this one. No, see numbering. 1, 2, 3, 4, 5, 6. So the answer was going to be hexane, not pentane. No. 1, 2, 3, 4, 5. So why don't you go like this? 1, 2, 3, 4, 5, 6. This one will now be having higher value. There will be 4, 4, and that will be wrong. So go like this. 1, 2, 3, 4, 5, 6. This is on carbon 3. On carbon 3. What will it be now? 3, 3, dimethyl hexane. Hexane. Let's enjoy the last one now. 1, 2, 3, 4, 5. For you to see double bond O, you are a member of the acanone, member of the words, or esters. Sorry, or the ketones, ketones, see double bond O. Acanones or ketones. So your name will be pentanone. That's the answer. Pentanone. Is it 3? On carbon 3, pentathione. So I also call it 3 pentanone. Bring it. You all have question now. Okay, I think we all have. That's what we have been waiting for. So let's go now. Question 41 to 50. 5 minutes. Let's go. (41 to 50). 5 minutes. Do it as if this is your JAMB exam. Don't just sit down like a lazy girl or a lazy boy. Just be as if you are lifeless. You don't have life. You have tried, but try more. Not, I'm tired. This chemistry we are solving now is chemistry number what? Number 10. That means it's 500 questions we have solved. Yes. And they will give you only 40. So we like say, I'm tired. I'm tired. And be putting head on somebody's shoulder. And it comes out and you cannot do it. It concern me. That 44, option D, there is a triple bond between the two C. Option D, there is a triple bond between the two C's. 44, option D, there's a triple bond between the two C's. When is sleeping beside you, please wake them or tell them to leave the class. Nobody's sleeping in my class, so if you're tired, go home. 5 minutes is gone, it should be true. A serious boy get out of this 10 should get 8 minimum. Some of it too much of play. "41, we have just done naming now, so nobody should miss that one. 1, 2, 3, 4, 5. So that'll be 2, 3, dichloro, Abi. 4, 4, dimethyl S2-ene. That's it, because you have to number from the double bond. Compulsory. Double bond has preference. Don't go and number from the other side. On double bond, so you have 2, 3, and you must have chlorine before methyl. 2, 3, dichloro. Then I have 4, 4, dimethyl X2. Is it S2-ene? S2-ene. You have to count that CH3 on top. So the answer is option what? Option C. Don't go and say 4, 4, 5. You are wrong, go. Because some of you pick option A. You're just pretending as if you pick that one. You have CH3 here. Hydrogen here. CH3. CH3. Chlorine. Chlorine. So you number like this. Because you double bond, you must start numbering from here. 1, 2, 3, 4, 5. You must go to this one. 6. So now see chlorine, that's on 2 and 3. 2, 3, dichloro, because there are 2 of them. Methyl carbon 4, 4, 4, dimethyl X2. In. That's the answer. 42. If glucose is heated with concentrated tetrazoate 6 acid, it will be dehydrated. Look at that. All glucose, all carbohydrates, when they are dehydrated, look at glucose. Glucose is C6, H12O6, or C6, H2O6. The word dehydration means removal of water. So if I remove this water, Mr. Water come out, I will just have C left. That's all. So the answer will just be ordinary carbon. Not carbon dioxide or carbon. The addition of sucrose will also give you carbon. All carbohydrates will undergo dehydration. We remove water, they will give only carbon left. So answer is A. 43. A hydrocarbon S with a molar mass of 26. Consists of this. What is it? Don't go and start doing rubbish. Carbon. Carbon 90.3. Who sent you message? Hydrogen 7.7. No. Molar mass. They gave you molar mass will be 26. That's enough. So go and find molar mass one by one. 12 times 2, 24 plus 2, 26. The answer is A. Abi. That's all. Don't go and start doing a drawing table. Divide by the smaller ratio. Divide by this. No. 12 times 2, 24. 1 times 2, 2. 24 plus 2, 26. And that's the value. 44. If you have been coming to classes, this one we have been doing many times. A rare residue of copper 1 carbide is formed when ammonium solution of copper 1 chloride is introduced into terminal alkyne. So the answer is what? B. You must have triple bond at the end. We've done it. That's step for terminal alkyne. Answer is B. Reduction of nitroalkanes. Nitroalkanes, nitrite, and amides. Claire, what is amides? Amide is this: RCO, NH2. And nitroalkane, RNO2. This is nitroalkane. Reduction of nitroalkane, nitrite, and amide is the root for pressure of. The answer is just when you remove CO, you're going to have RNH2. So the answer is amine. That's the answer. Not detergent, amines. Amines. How do we form detergent? By the word alkaline hydrolysis of sulfonated alkenes. That's how detergents are formed. Alkaline hydrolysis of sulfonated alkenes. Not by natural alkane. So the answer is A. The major product of the dehydration of the above compound. When you dehydrate, what are you trying to do? Remove water. I've taught you what to do. By removing water. See this guy, CH3. Maybe I should even write everything for you. Like this. OH, come here. How do you remove water? You can only remove water from what? Adjacent carbon molecule. From here. That's how we do. Remove water. This is water. So you're not going to have this CH3. C, this one here. CH3. Once you remove two things like that, there was a double bond formation here. You now have H, now CH3. CH3. So the answer is CRB. That's a C. Remove water. Look at that. Reduction of alkanone. Class, when you oxidize primary alkanol partially, I heard Damon said all this yesterday. When you oxidize primary alkanol partially, what are you going to have? Complete oxidation, what will it give you? When you oxidize secondary alkanol, what do you get? Alkanone. When you now reduce alkanone, what do you get? That's the answer. Secondary alkanol. 48. The product obtained when a mixture of benzene vapor. What is benzene? C6H6. Are passed over a nickel catalyst at 180. Look at that. C6H6, benzene. They now put hydrogen. So you're going to have C6H12. And to maintain that kind of ring, you are still going to have cyclohexane. That's the answer. Cyclohexane. A. So why? Benzene has 6 carbon atoms. But then I put 6 hydrogen atoms to join them. Now I have 6 carbon and then 12 hydrogen. Still in a ring structure. Although the aromatic structure will have been broken. You just have cyclic form. Cyclohexane. And the process is called hydrogenation. It's called what? Because nickel is very useful when you are trying to hydrogenate. Opino mentioned hydrogen of oil, giving us what? Margarine. Using nickel catalyst. Polyvinyl chloride is used in the production of what? Pipes. We said that one many times. Detergents are manufactured with straight hydrocarbon chains so as to make them what? What do you know about degradability? To be broken down by a natural process. See, some people in this class got 10-10 here. And they're not the best student in the class, but because they've been reading small, they've been looking at past questions. Some got 9, some got 8. So if you are still getting 2, 3, you have to do more work. Let's go now. 1 to 10, quickly, 5 minutes. I know you are tired, but give more time, give more effort. All my leg now is aching me like mad. It's not that maybe it's convenient for me too. One to 10. The one you can't remember, skip it. Skip it. That number 4 is 16.8 gram. Number 4, 16.8 gram. By now it should be true. 1 to 10. There's nothing wrong in all these 1 to 10. No. Question 1. Chlorophyll obtained from given leaves of plants. From green leaves, not given leaves. Don't mind them. From green leaves of plants. Chlorophyll obtained from given green leaves of plant can be shown to be composed of more than one color component by the technique of chromatography. Abby, we've done how many times chromatography for ink, for dye, for chlorophyll. Number 2, in country where the temperature fall below 273 Kelvin, 273 Kelvin is what? 0 degrees Celsius. Abby, salt is always sprinkled on the icy road in order to lower the melting impurity, lower melting point. 2, raise your hand. Don't lie, you. That's it. 3. So you'll be shocked to know that some people still get 0/2 in these two. Okay, we spoke about the effect of impurity 2 days ago in physics class. From the equation above, calculate the mass of sodium hydroxide produced by 2.3 grams of sodium. You don't have to mix coin like this anymore. So this one is going to be 2 into 23. Abby? How to put it 2? For calculate the mass of sodium hydroxide produced. 2 into 40. Sodium hydroxide is 40. So we now have 46 grams. Give us 80 grams. And then 2.3 grams. Give us X. You have 46X. 2.3 times 80. So our X now be 2.3 times 80. All over how much? So what's the answer? 4 grams. Number 4. 16.8 grams of sodium hydrogen carbonate is completely decomposed. 16.8 grams. I corrected it. Now you must write the equation. That is sodium carbonate plus water plus CO2. So you need 2 here. Let's calculate the volume of carbon dioxide. Now, sodium is 23 Ab, hydrogen 1, carbon 12, oxygen 48. So that will be 2 into 24 plus 60, 84 Ab. And we're going to have 168 grams. Because this is CO2, is a gas. And the answer is in dm cube. That will be 22.4 dm cube. Abi now? And now you should be getting all these calculations. Then 16.8 grams. Just move this guy one step. Sure you know. The answer is 2.24. Is that the answer? That's it. There is nothing here. So Ix 16.8 times 22.4. All over 168. Answer 2.24 dm cube. All the one we have done, be so know them that if they mistakenly repeat some of them, you get them. That's the goal, oh. No, sir. Some of the things you taught us came out. Then what you did not score? 219. No. Say God forbid. If it is 219 you want to score, we won't be doing this extra effort now. This public holiday, we should be sleeping, be resting. Number 5. Okay, with gas has a pressure of 800 millimeter mercury. If the pressure is reduced to this, Anything Boy's law, Charles law, you should get all of them, Abby. What are we looking for? Volume. Is that Boy's law? P1 V1 equals what? What's P1? 800. What's V1? What's P2? What's V2? So V2 now will be what? 800 times 300. Calculator, what do you get? I can't tell you. 369.23. Number 6. Diffusion is slowest in solid particle. What is diffusion? The movement of what? Molecule from region of what? Now the diffusion is slowest in solid particle than in particle of liquid and gas because solid particles have more kinetic energy. Is that true? No. They don't have more. They can't even move about. They don't have energy. B. Solid particles have less kinetic energy than the particle of liquid. That's the answer, B. The answer is B. But let me see. Go through C. Solid particles have less restriction. No. They have more restriction. The particles in solid are far apart. No. 7. The experiment that showed that atoms have tiny positively charged nucleus was first carried out by who? Rutherford. The center of an atom is positively charged and the mass is concentrated in a tiny volume called the nucleus. What is the work of Moseley? You have not heard of Moseley before? What did he do? What did Moseley do? X-ray call. Gamma ray. What is the work of Moseley? Yes. Who is raising hand on the back? I can't hear. Hydrogen carbon. Atomic number. Who gave us periodic law? Very good, Mendeleev. Who gave us that charge to mass ratio of an atom can be calculated? J.J. Thomson. Who gave us charge of an electron? Very good. Moseley is talking about the atoms, the nature of the atoms, nature of an atom, just like Dalton. Number 8, the atom of an element X represented as YZX. These are X now. YZ. Class, the chemical property of an element is determined by the number of electrons the element has. And that's that Z. So the answer is Z. Not Z minus Y, or Z. The basic chemical property depends on how many electrons you have. Number 9. That element is 1s2, 2s2, 2p4. If I count 2 plus 2 plus 4, what's that? 10 call 24. Already sleeping. 8. The 8th element on the periodic table is who? Oxygen. Akinola, are you okay? I've not been seeing you. Bale. Oxygen. Alright, 2 plus 2 plus 4. 10. Put it rare. Your brain is tired. Number 10. In the periodic table, electrical and thermal conductivity are properties of elements. As we are going across the period, from lithium to beryllium to boron like that, what happened to electrical conductivity? Is it increasing or decreasing? Decreasing, because those are non-metal. They can't conduct. So it decreases across the period. What happened down the group? Increases. So the answer is what? A. Let's go now. 21 to 35 minutes. Of that one, try and get 10-10. You can.